than 0. So yeah, definitely right there, mean weight loss. So we're definitely doing a hypothesis test on an average, on a mean. They could switch this around and say 76 subjects placed on low-fat diet, 42 of them lost more than 2 pounds. Do we have enough evidence to say the proportion of people that lost more than 2 pounds is more than 0.6 or something like that? So, I mean, you know, you've got to just look at the wording. Are they looking at it as a proportion of a sample or of an average of something? In this case, I'm actually looking at the pounds lost, so it's an average of pounds lost, and I want to see if the average weight loss is greater than 0. So my claim, we're going to start with that, is that the average weight loss, the population mean mu, is greater than 0. The mean weight loss is greater than 0. So mu is my mean weight loss. My claim is that it's greater than 0. My null would just be that it would be equal to 0. And actually, it's nice to put in here, these are kilograms, so it's really nice to label this too. Kilograms. Good. Everybody okay with where we got that null and alternative hypothesis? All right. Can we assume that the sampling distribution of the mean is normal? Explain your answer. What are your ideas on this one? So this is kind of what we had to do, similar to this. Kind of one of these two things.
Greater than or equal to 10.
So if
No.
they pull 76 subjects, it's a large enough sample that we can assume that the sampling distribution of the mean is normal because of the large sample size. That would be my answer. I'm curious, what did they have in there?
That's what they said.
Perfect. Because I didn't have an answer key. So some of these I'm always like, well, I don't know. Because every instructor is a little bit different. But yeah, it would have to be that. I mean, there's no other way around it. If I know that, so it goes back to that sampling that you guys learned about way back in chapter 8, where if you're sampling enough people, then we can kind of disregard the underlying distribution of the population and treat it as normal. So, yes, since n is greater than or equal to 30. Pretty much it, yeah. If the sample size is large enough, we can just treat it as a normal distribution. All right. Use the following information generated by the tab. Give the value of the test statistic, write it below. Explain in detail what the test statistic measure in the context of the problem. So which one of those two numbers is the test statistic?
The t-value.
The t-value, right? It could be a z-value if it was a proportion, but yes, the t-value is the test statistic. And so that t-value is equal to 3.14. What it's measuring is pretty much how extreme your sample is if the underlying null hypothesis was true. So when we go and pull a sample of our 76 subjects who are on this diet, and we find that the average weight loss is 2.2 kilograms, this test statistic is telling us how odd or how extreme this sample is, if this was true. So if that we would expect the average weight loss to be 0, the test statistic is a representation of how extreme the 2.2 kilogram weight loss was. The p-value is the probability of that, which we'll talk about in a second. But this just measures how extreme our sample mean of 2.2 kilograms is if the true mean weight loss is 0 kilograms. I'll put myself on the spot now. What do they have?
They said it's representative of the standard deviations from the population.
Okay, that's good too. That is that is a good way of looking at it too, is how spread out it is, how extreme it is. Yeah, good. This was my first, I know last time they liked doing the extreme as an extreme, and that's what they kind of do with the p-value too, so. All right, so give the p-value and explain what it measures. They're not asking you to make a decision, but just explain what it measures. So, the p-value is right there, the 0.0012. So, very similar, but this is just the probability that we would get a sample weight loss of 2.2 kilograms if the true average weight loss was 0 kilograms. So, this is the probability of obtaining a sample mean as extreme or more extreme, because it could be even higher, like even higher of a weight loss, or more extreme then, instead of just saying then the one that we got, I would actually put what we got. The sample here was 2.2 kilograms. So this p-value is the probability of getting a sample of weight loss of 2.2 kilograms or more extreme. If the true mean weight loss, you can keep going, the true mean weight loss is 0 kilograms. So it's the probability of obtaining a sample that you got if the null hypothesis is true. In this case, the null hypothesis is that there is no weight loss. The weight loss is 0 kilograms. So if that is true, the probability that I would have observed an average of 2.2 kilogram weight loss, that probability is 0.0012. The lower this is, the more it means extreme, the more extreme our sample is, if the underlying assumption is true. And that leads into the rejection decision. Because if the p-value is very, very, very small, then that means what we observed is very rare if the underlying condition is true. So therefore, we have enough evidence to say that the underlying condition is not true, and we can go with the alternative. And that actually comes up in the multiple choice questions here in a second. So now, the way we decide if it's small enough or not is if we compare it to the significance level. And so you guys might have heard Lori's thing. I'm not going to write it on here. But you know it. Everybody knows it. If the P is low, reject the hoe. And so it's very easy to remember. But what it means is P is p-value. It's not the probability proportion or anything like that. And then again, HO is the null hypothesis. But that's pretty much what it's saying. If the p-value is low, you're going to reject the null hypothesis. But an easier way to remember it, because sometimes you're like, oh, and this was me when I took my first stats test. I was like, okay, p-value, was it P is less than alpha reject or P is greater than alpha reject? And I was trying to remember which way it was. But this is helpful. If the P is low, reject the hoe. And that's where you know. So in other words, if the P is not low, you would not reject the hoe. So low meaning lower than the significance level. So the p-value was 0.0012. My alpha level is 0.05. Is the p-value lower than alpha?
Yes.
Okay, so make sure it is yes. But make sure you can properly compare decimal points. And if you need a little refresher, it's pretty simple. You start at the decimal place and walk to the right until there's a discrepancy. These first two zeros, so that's not enough information. The next hundredths place, this is a 0, this is a 5, that one's larger. Yeah, anyway. So, since the p-value is less than alpha, we will reject the null hypothesis. Yeah. And there are ways you can compare the test statistic to a critical value, but